This animation shows the basic components of a fluid power system, which are essentially the same regardless of whether the system uses hydraulics or pneumatics. The different parts of a fluid power system can be conveniently located at widely separated points, since the forces generated are rapidly transmitted over considerable distances with small losses. When a fluid pump operates, it performs two functions. First, its mechanical action creates a vacuum at the pump inlet, which allows atmospheric pressure to force liquid from the reservoir into the inlet line to the pump. Second, its mechanical action delivers this liquid to the pump outlet and forces it into the hydraulic system. The rotary actuator shown here consists of a sealed chamber divided into two parts. The actuator is designed to rotate in either direction by high-pressure hydraulic fluid entering either fluid port. The rotating shaft will then turn in the direction of the force exerted by the high-pressure fluid. When a solenoid valve is connected between the cylinder and hydraulic supply, the cylinder rod will extend when the valve is energized and fluid flows into the cylinder. When the valve is de-energized, the piston retracts and the cylinder rod is drawn back into the cylinder either by gravity or by a return spring. When the solenoid coil is energized, the core is pulled into the coil and the lever is moved to open the inlet port and close the exhaust port. This allows pressure to enter the diaphragm housing and open the valve in the main line. When the solenoid is again de-energized, the solenoid inlet port closes, the exhaust port opens, and the pressure in the diaphragm housing is let out the exhaust. The thin disc rotor stepper motor dissipates much less power in losses such as heat than the cylindrical rotor, and as a result it is considerably more efficient. Efficiency is a primary concern in industrial circuits such as robotics, because a highly efficient motor will run cooler and produce more torque or speed for its size. The basic construction of a direct drive joint is shown here. The inner and outer cases are connected to other joints by connecting links. The motor illustrated is a DC torque motor which consists of a rotor, stator, and brush ring. The stator and brush ring are installed in the inner case, while the rotor is directly coupled to the outer case without any transmission mechanism.